Welcome to this explainer on scientific behavior and ignored ideas. Today, we're diving straight into a really fascinating framework proposed by physicist S.J. van Stekelenburg.
We're going to explore exactly how ideas evolve from mere shower thoughts into accepted science. It's vital to realize that a lot of legitimate scientific ideas, they don't start out in some pristine, sterile laboratory. They often start as just mere speculation. You might literally just be taking a shower or doing something completely unrelated to science when, bam, inspiration strikes. But the big question we have to answer is, when does that completely random idea actually cross the threshold and become recognized as science?
Well, the standard path of an idea is actually pretty structured. First up, it has to be recognized as a legitimate scientific idea. Once it is, and assuming it isn't immediately disproved, we move into the phase of constructing and experimenting. Now, the entire goal here is to try and prove this refined idea wrong. Seriously, and if the scientific establishment continuously fails to disprove it over time, then, and only then, does that idea gradually become mainstream. It's a rigorous, honestly beautiful process.
Now here's where it gets really interesting. What happens when an idea doesn't seamlessly fit in? Our physicist outlines that there are essentially 5 different situations a new idea can face. 4 of these situations, like where people are actively trying to disprove it or everyone's just trying to make it work, are perfectly handled by the standard scientific method. We don't really need to worry about those. But that 5th category? Oh, that is the one we absolutely must worry about.
This dreaded 5th category is called ignored science. It happens when a new idea is put forward, the creator is desperately trying to make it work, but the rest of the scientific field just completely ignores it. Crickets. So the crucial point to understand here is that in this dangerous zone, the objective scientific method gets completely taken over by a sociological method. The new idea isn't tested, it's just judged. As the source material points out, it gets treated almost like witchcraft. But this naturally begs the question, right? Why on earth would an established scientific community, people whose whole lives are dedicated to discovery, choose to simply ignore a new idea rather than actively engaging with it and testing it out?
The source highlights a few highly pragmatic, though pretty unfortunate reasons. First off, these ignored ideas carry a ton of uncertainty regarding their content. Plus, there are massive money and time issues involved in pivoting to study them. And sometimes these new ideas pose a direct danger to the establishment itself, creating a potential slowdown in the growth of already established, well-funded science. Honestly, it's just easier for the system to look the other way. Because this 5th category is the only situation we genuinely need to worry about. Since, the other 4 basically take care of themselves through the scientific method, it is absolutely crucial that we learn to recognize the specific symptoms that an idea is being actively ignored. You can usually spot ignored science when questions are simply not asked, or they're just left completely unanswered. Doors are closed, scheduled meetings suddenly don't happen, and communication becomes strictly one way. But most dangerously, you know an idea is being ignored when the establishment attacks or discusses the person presenting the idea, instead of discussing the actual content. In extreme historical cases, people have literally disappeared or been thrown in jail over this stuff. And historically, we've seen this exact sociological pattern play out. Think back to when early thinkers first argued that the Earth was a sphere. Meanwhile, everyone else in the establishment stubbornly insisted it was flat. Those early sphere Earth proponents, they weren't immediately debated with scientific rigor. No, they were often ignored, mocked, or persecuted until the evidence just became entirely undeniable. But hey, this phenomenon isn't just ancient history. The source provides a super fascinating modern example. There's a mathematics professor who has spent decades demonstrating that the standard textbook definitions of infinity and continuity are fundamentally flawed. He has literally been asking for years if anyone can give him a proper, scientifically sound definition.
In a healthy environment, you'd expect the establishment to either show a proper definition armed with strong arguments, or humbly admit that the professor's reasoning is correct. But the actual reaction? Neither. The establishment has simply ignored his reasoning entirely, placing his highly researched work firmly in this dangerous 5th category of ignored science. Fortunately, there's a silver lining here. We're seeing that technological advances are really breaking down these traditional institutional walls. Technology is supporting new, incredibly open modes of communication. And this is slowly helping to shift opinions and bring much-needed attention to these ignored ideas, basically proving that while institutions might ignore them, the connected public absolutely doesn't have to.
Practicing good scientific behavior online.
So how do all these grand rules of scientific epistemology directly apply to the micro level of our daily lives? Well, it all comes down to how we behave in internet comment sections. When someone puts their hard work online, responding to it with emotional or relational comments like, "I hate it," "This is bad science," or "You're a bad person," is the exact same toxic behavior the scientific establishment uses to ignore new ideas. It's just not an argument. Contrast that with actual scientific arguments like, "Hey, can you explain this specific thing?" Or, "You are wrong because of this specific evidence."
So the really crucial point here is this. Throwing out relational attacks might successfully scare away people who have genuine scientific intentions from taking notice of the work. But scaring people away absolutely does not fulfill the scientific obligation to disprove an idea using evidence and argument. It's a sociological defense mechanism, plain and simple, not a scientific one.
To combat this kind of thing in digital spaces, our Curious Physicist creator made a really fascinating decision. He literally throws out and removes comments from his channels that are purely emotional or relational. Things like, "I hate it," "I love it," or "I do not agree, period." Why? Because there are already like and dislike buttons designed perfectly to satisfy that specific urge. They just don't belong in the realm of actual discourse. On the flip side, the comments he keeps are those that actively engage with the content. By only keeping comments that ask genuine questions like, "Can you explain this at time X?" or present structured arguments, even negative ones like, "You are wrong because of Y," we can applaud and foster true scientific behavior. Even encouragements are kept around, provided they actually contain an argument for why the new idea is good.
Which brings us to our final takeaway. There is a scientific obligation to disprove an idea using arguments. So the next time you're reading about a controversial new theory, or you're just about to fire off a comment online, I want you to stop and ask yourself a question. Are you fulfilling your scientific obligation to actually argue the content, or are you just contributing to the dangerous culture of ignored science? Think about that before you hit reply.